Good afternoon and welcome back to the Workbench. So this will be a hopefully repair video about this power supply here, computer power supply. Now this one is a pretty basic thing, CoolerMaster RS-400-PSAR-13. I have no idea, I've never heard of this before, but you can see 400 all over it, so it's probably about a 400 watt power supply. CoolerMaster are not the most amazing, and this seems to be quite a low end one, so not really worth going too much trouble to repair it if there's something significantly wrong with it, but maybe worth fixing if it can be done cheaply and easily. So the story with this is I found it on the side of the road in a rusty old computer case which I didn't bother keeping. But I pulled this because I thought, hey, it looked alright and why not? You know, you got the nice big fan on there, it's a half decent one, maybe worth keeping and having a look at. On close inspection it turns out there's definitely something wrong with it. So just looking from the outside, and I'll go into that later what's wrong with it, we look at this, I mean you can tell by looking through the grill and everything, but for a start we see this voltage selector switch, so that switches between the 230 and the 110, 115 volts for different countries, different line voltages, so you can see straight away this doesn't have active PFC, and you can tell by the looking in there and the weight that it doesn't even have passive PFC either, so it's pretty basic design, which is kind of good because it might be easier to fix. Active PFC circuits sometimes blow up, they can be quite expensive to repair depending on what's gone faulty. Sometimes the coil even goes bad, so you know, the kind of good thing with that, there's none of that there, so that makes it kind of simpler, so that gives it a bit of hope. Also you can say, well, someone might have flipped this switch and blown the power supply up. Could have been what happened. Who knows? So keep that in mind too, because if someone switches that to the wrong voltage and then plugs it into the 230 volts, most likely, you know, you're going to have pretty big problems. Secondly, have a look at the warranty screw. We can see it's already been opened. The seal here is broken, so you know, someone's already been in there, so there's another indication that there's something wrong with it. And yeah, I mean, it's chucked out, so you could say that that's another sign too, although a lot of times people will throw things away that still work perfectly fine, so that's not the best indication. Just because something's in a dumpster or chucked out doesn't mean that it's bad. In this case, I mean, I know that it's bad because I've looked through the side of it and I can see something. Another thing, interestingly enough, someone's cut off some wires here, so we've got some ground wires there, we got some 12 volt wires here, so it looks like someone's cut off maybe a PCIe connector, or I mean we got the aux 12 volt for the main board there, so it can't be that, but they probably cut off a PCIe graphics card external power connector, or something like that, because there's not really anything else that could be there. For something like this, I mean the hard drive connectors have 4 or 5 wires, so it's not going to be that. But that's good. I mean, that's not really necessary. You could still use it without that, or I could get another one and solder it on if I really wanted to. That's not too much of a problem. But the thing with this, and I'm not sure if it'll show up on the camera or not, because it's quite dark in here, but hopefully I'll give it a try. I don't know if it'll work, but you can see, or maybe you can see, but in any case, to look straight through these through the back grill here, looking at the fuse there, I can see that the fuse has exploded. So it'll be a glass fuse, it's obviously blown hard and exploded. So that tells me straight away there's definitely an issue on the primary side, which could indeed have been caused by someone flicking the switch and plugging it into the wrong voltage. Or it could have just gone faulty by itself, which of course can happen. So that immediately brings to mind to me either hopefully a simple fault like shorted bridge rectifier, which is common, or shorted primary capacitor, less common but still can happen, or shorted primary side MOSFET or MOSFETs, or transistors, whatever they are. This is kind of looks like an older design, so it may not actually use MOSFETs. It might use bipolar transistors on the primary. But typically, yeah, those three things: either the primary switching transistor, the bridge rectifier, or the main filter capacitor. One of those three things could have gone faulty and blown the fuse hard like that. Any of those three things could have failed because of the switch being set to the wrong position. Two ways this thing could go. Could just be like I said, bridge rectifier shorted, replace that, it's fixed, 5 minutes, no worries. Or it could be that the primary transistor's blown, and they've taken out the drive circuitry and they've burnt like a whole bunch of components, and we don't know what the values are, you can't replace them, and it's not worth bothering with. But we won't know that until we open it. So I'll open it up now, and we'll have a look and see what's going on. I have not opened this before. I don't know anything about it apart from what I've just said, looking in the side where I can see the blown fuse. So we do know that something's definitely gone bad. Most likely short. There's no point in plugging it in at all at this point, so I'll wait until I have a better look at it, see what's going on before I bother trying to give it power, because at this point there's completely no point. So we get that off. There we go. So that's the inside of that. So you can actually see, it's pretty small really. We don't have a lot of stuff in here. The heat sinks are rather small. It's pretty basic. So it's not going to be amazing, but we got all the filtering and everything there. I mean, it's good quality, but it's not high power. Anyway, you can see some of this crusty glue on this fan connector. So I mean that could be. Let's see if I can unplug that. Okay, that can come off there. That's good. Okay, we can get that out of the way. Solve that problem. So yeah, let's have a look at it. So what I'm looking for is basically exploded things. We know the fuse has blown up already, but we want to look and see if we can find anything else. So look at the bridge rectifier, it looks okay. Can't see any scorch marks there. These capacitors look alright. There is something. I can see two things blown up in here, and they look like MOVs actually. So that's interesting. These blue things there in the middle where I'm shining the torch have exploded. Now those are metal-oxide varistors, it looks like. They do look kind of similar to these, say, ceramic capacitors here, but they're not the same. You can get them confused because they are same color and they look very similar, but these are designed as surge protection against spikes and stuff on the power grid from lightning strikes and that kind of stuff. So these are designed to clamp the voltages down, get rid of any spikes that might damage the transistors and stuff. And those both here have blown pretty hard, and you can see soot up the side of this transistor, and you can see soot on the side of this capacitor. It's definitely exploded just like the fuse has. So these have seen significant voltage and current, and they on the output of this voltage selection switch, so it's quite possible that someone has actually flipped that switch either accidentally or deliberately and blown these up. So there's a diode here. I don't know if you can see. It's got one leg blown off, and this resistor next to this one here looks a little bit burnt, but I don't know if that's just from the soot or if it's actually gone faulty. There does seem to be a little bit of soot on this red capacitor here. I don't know if that's from some arcing maybe on this resistor here, or if something else is blown. But yeah, these two have definitely blown. This diode here, can't see any burn marks on these transistors, but they could have failed without exploding. If they did see a high voltage spike, you would hope that these did actually function and clamp the voltage to prevent damage, but you never know. The fact that diode there looks like a snubber diode for this transistor is also blown. Yeah, it's a bit worrying. So this transistor could be bad too. Only way to find out is to pull it out and do a test. So what I'm going to do is desolder these, take them out, remove that diode, remove all the parts that are obviously burnt, and try and figure out what's going on. And then obviously I'll check these for shorts, see if they're bad. Obviously to power it up I'd have to replace that diode, but I can get away with taking these MOVs out because they don't have to be in there for operation. I might have to replace that resistor. Don't know if that's any good. I'll have to check this capacitor and maybe the components around it to see where that sort of burn mark came from. I mean, it could have just been from these blowing up, but it's kind of over in this corner, so it's kind of odd. But yeah, I mean, if it's just these that have blown, this might actually be fixable. If it's these transistors that have blown as well, you know, maybe not, or at least maybe not worth fixing. I mean, I can see, looking at the drive circuit, this has got a, this is driven from the secondary side with this IC here, and then we've got this this transistor driver transformer in the middle there. So this will be the 5 volt standby, this will be the drive for the main one, this is the main transformer. Nothing down there looks blown that I can tell, but we won't really know unless I check all this and then power it up. So the good thing about that diode, it looks like it's the only one that's blown. The other one still looks intact from what I can tell, so I should be able to pull the part number off the other one if that one there is too burnt to read. I mean, that's the main problem with these things, because there's so many different designs, you can never really get schematics for these at all, so finding a specific part number is practically next to impossible unless you can find another identical power supply or find someone else with one and ask them to have a look for you. But yeah, if something's burnt beyond recognition, it's unfortunately not that easy to figure out what it was. Usually. Okay, so I finished pulling the obviously bad parts, and I'll just have a look and see what the verdict is. So, start with these capacitors. I mean, these are probably still perfectly fine. I haven't actually tested them yet, but you know, they're not shorted or anything, so that's good. This capacitor here is probably still fine too. There was a little bit of soot on the side of it, which I thought might have been from a burn hole or something, going shorted as well, but that seems fine. It was just soot on there. I guess it was just soot done from these exploding MOVs. So there you go. You can see those have those are very nicely exploded. They're very burnt. So you know, the amount of power to do that, we're not really talking about you know, a brief surge or something. This is either a significant power surge or from someone flipping that selector switch to the wrong position. That would definitely do it. The other one is, I mean, this one is blown open. This one is basically just completely vaporized. You know, there's just the two outside parts left, and the center material is just gone. There's nothing else left of it. Same with the fuse. You just got the end caps, practically nothing else. A little bit of glass. So yeah, those are definitely blown hard. The transistor here with soot all over it is actually bad, so that's gone open circuit now. I don't know if it failed shorted and then went open, quite possible. I expect it saw a quite high voltage, and then, you know, these things are rated to say 600 volts, but it probably saw more than that. So yeah, that's definitely bad. Obviously the diode, I think the snubber diode for it, that's obviously blown up. You know, one lead is just missing completely, so that's no good. Checking with the other one, its diode is okay. These are a PR-1007, so it's just a sort of a generic fast rectifier diode, which is, you know, what you'd expect there. This other transistor is actually still testing out as okay, out of circuit. I'll probably replace it anyway, because obviously, you know, these are kind of in a pair. If you get another one, you kind of get mismatched, so, and it could be stressed anyway from the problem, so it makes sense to replace those, just the whole lot, if you're going to do that. Another thing was this resistor here, a 330k. It actually still measures fine, although one of the leads is blown off, so I guess that was just from some kind of arc from maybe one of the MOVs to that lead that just burnt the lead up. That's the other part of it there. So yeah, that needs to be replaced. Not burnt up, but needs to be replaced. This diode, 1N4148, just standard little signal diode, that was in the base drive circuit of the blown transistor. So this diode here is shorted, 150 ohms both directions, so you know, it's bad. And a couple of wire links which I decided to pull because they got melted bits on them and soot and stuff and didn't look very good, so I'll replace those too. So yeah, that's pretty much it. I've got these sill pads for these. Probably, well, you're not supposed to reuse these anyway because they're kind of only a one-use thing. But of course, if the transistor has seen an overvoltage condition, it could be possible that these might break down because of a high voltage. I mean, there's no actual signs of that, but yeah, I don't know, you have to have a significant overvoltage condition to punch a hole through this. But it can happen. Something to check for if you've got something replaced that's blown up. I mean, also if a transistor blows up, it could physically blow a hole in this from the explosion. If these things explode, this one hasn't, but it's definitely bad anyway. So that seems to be it. Everything else seems to be alright as far as I can tell. So I think it's probably a case of replacing these few components, and it probably will work again. I think I will give it a go because these transistors are fairly cheap. Pretty common, pretty cheap. You can get them just about anywhere. So yeah, I mean, a couple of dollars for that, and I've already got resistors, diodes, MOVs I can pinch out of something else, or buy new ones probably for next to nothing. So very common parts. So nothing highly expensive. Total past costs is probably like less than $5. So yeah, for a power supply that's not too terrible and has a nice large fan in it. Yeah, I mean, a few dollars, kind of worth it. So I'll give it a try. Well, I'll do a test in a second, just to ensure that the rest of it's okay, or at least that it's mostly okay. Because the 5-volt standby circuit could have blown up. I don't know. There doesn't seem to be any damage there, but haven't tested it. So what I want to do is I'll put these capacitors back in. I'll put a light bulb in place of the fuse to limit the current in case there is another fault, and I'll power that up and check the 5-volt standby is working. If that's okay, and also I'll check the secondary rectifiers to make sure they're not shorted or anything obvious like that. Just do a quick test. So if those two tests come out fine, I would say the damage is most likely limited to these parts here, and can replace those for a few dollars, and it'll probably work again. Okay, so time to test this thing with some actual voltage and see what happens. Obviously I haven't replaced everything yet. I put the capacitors back, I tested them out, they all seem fine. The ESR on these was the same, 0.14 ohms, and the capacitance is the same at 670 microfarad, which is a little bit low. They are measured at they're rated at 820. Measuring them at 670 is almost minus 20%, so they're a little bit low, probably old or just cheap, or both. But as long as they're matched, it doesn't really matter. Anyway, so I've replaced the 330k resistor. This is the discharge resistor for these capacitors, so that's not a big deal to leave that out, but obviously as a safety thing you should put it in there, so I replaced that. Haven't replaced the MOVs because I don't need them for testing, and the transistors obviously I've just left out because all I want to test is the 5-volt standby at this point. I've wired this bulb here in place of the fuse. It's a 60 watt bulb, so that'll limit current if there is a fault with a 5-volt standby. I don't have the right fuse around, so it's easier to do that anyway, and saves you wasting fuses in case there is actually a fault. It's all ready to test, so I'll just plug it in and see if it explodes. So I'm going to put the lid on just as a thing, and I desoldered the wires that were cut off for the video card power connector, and I've actually used a couple of them to wire this light bulb up. So yeah, just remove those. There wasn't some loose wires floating around to cause any problem. So that's switched on there. Make sure the switch is actually the correct voltage, so 230 volts for me, and yeah, I shall plug it in. And what we should see is this bulb should light up briefly, and then it should go off or go to a very low amount. Basically how this works is light bulbs have a very low resistance when they're cold, but they go up to a higher resistance when they're hot. What it does is the initial current will be fairly high, but as that current goes through the light bulb, it'll heat up and start glowing. As it heats up, the resistance increases, and the current then gets limited to 60 watts or whatever your bulb is. Of course, this only works with incandescent bulbs, doesn't work with, you know, LED or CFL or anything like that. It has to be a plain old standard bulb, tungsten. If there was a short circuit in this would just light up brightly, at the normal brightness that it would light up in normal operation, and it will limit the power to 60 watts. As it is rated on here, and that should be plenty for a 5 volt standby, but not too much that it'll let anything blow up too violently if there is an actual dead short somewhere, or one appears. But yeah, so I've got my power here and plug it in. Well, that's not good. That lights very brightly, so we can see there's still a problem. Now what is most likely with that is probably the bridge rectifier, because I forgot to check that. So there we go. I completely forgot to check the bridge rectifier because I just assumed for some silly reason that it was fine, but hey, dead short. From both negative and positive to the AC there, so not across the center pins or the outer pins themselves, but yeah, it's definitely not looking good. So alright, well, that bridge rectifier is definitely shorted. So here's the one that I just pulled out of here. We can see from the output pins to the AC we've got a short there. So from one of the diodes from this pin to this positive pin is short. The other one is actually okay, getting 500 millivolts there. From side to side we're getting 500, which makes sense because we've got a shorted and a good diode in series. And from this other side we've got one good and one shorted. So yeah, half of this bridge rectifier is shorted. So yeah, that's no good. This one is one I just pulled out of an old AT power supply, so it's probably like 200 watts or less or something, so it wouldn't be good for replacement in this permanently, but for testing just the 5 volt standby and everything, it should be fine. So to test this properly, you need to get your leads around the right way. So this is the positive pin on the left hand side, this is the negative pin on this side. You have to put your probes backwards to that, so the negative goes to the positive, which kind of doesn't make sense, but when you see the internal schematic and the way the diodes work, it actually does make sense, because the cathode of the diode, you got one diode coming from here to here, its anode will be there and its cathode will be there, and another anode from there and a cathode there. So you're actually putting the positive on the anode of the diode that's between this pin and this pin, and obviously the cathode is a negative. So we should be getting these leads are a little bit dirty. This thing is probably about 20 years old. So we're getting 540 millivolts to that one. Should get about the same to this one. Okay, we've got 550, and then the two diodes over here should be the same. So we just tick that. We get 540, and over here got 540 as well. And between these two, we should get a double diode voltage drop. So about 1.2 volts. So yeah, 1200 millivolts. That looks alright. And between the two AC pins we should get absolutely nothing in both directions. So yeah, that seems fine. So this one checks out fine. And also you want to check each of the four diodes. The voltage drop between each one should be roughly the same. In this case it is, it's about 550. If you get one, say like 450 and the rest are 550, well, the one with the lower voltage drop is going to carry more current, it's going to overheat. There's going to be an imbalance, it's more likely this thing will blow up over time. So yeah, if the four diodes are mismatched in some way, more than say maybe 20 millivolts or something, then that's not a good thing. So you want to test for that as well. But this one looks alright, so I shall put it in the power supply, and we should see what happens. Alright, that'll do. So put the lid back on in case the capacitors explode or something. Unlikely to happen, but yeah. Okay, and get my multimeter back in case it actually works this time. So I'll stick that there. I don't know, I'm, well, somewhat confident it'll work. Let's grab the power connector. Power lead, that's on. Okay. It's good. switch it on, make sure that's on 230, it is. So what we're looking for here is this light bulb to flash briefly and then go down to practically off or a very dim level. That'll be when the capacitors charge up, and then of course the only thing taking power will presumably, hopefully, be the 5V standby, which will be taking practically nothing because it won't be supplying any power to anything really. And yeah, that's what we should see. So as you saw before with the shorted rectifier, it just lit up brightly as it normally would if you just plugged it into a socket. In this case it should hopefully just light up with a flash, which it does. So that's what you'd expect to happen. So that's good. So I can turn my multimeter on to 20V range. You can grab the power connector here, and just remember that these leads are really short. Should probably attach some better probes to this or something. So we got purple wire, that's that one there. So purple to ground. Sorry, it's confusing me because it's a 24 pin. So there we go. 5.11, 5.17? No, 5.11. So there we go, 5.1 volts. So the 5V standby is running. Nothing's blowing up. And yeah, it looks good. So that's, well, not fixed obviously. Half the parts are still missing. If we try to power this up, obviously nothing will happen. But yeah, should be able to measure that. We've got 5V standby there. The PS on signal should be at 5V as well. Or, well, 3.3, that makes sense too. Everything else should be off. Power good should be low, which it is. So yeah, so we've got a 5V standby. We've got a high logic level signal, 3.3V on the PS on, so that makes sense. And we got nothing on power good, because that should only go high when the power supply is started and it's verified that all the voltages are in spec, and then it sends a power good signal to the motherboard to tell the motherboard that everything's okay. Really cheap and crappy power supplies just wire that line directly to the 5V or 3.3V rail and do no actual voltage comparison or anything whatsoever. So yeah, but anyway, so that all seems to be right. So yeah, I guess it's worth to continue on. I'll order new transistors for this, and diodes, and MOVs and everything, and then I'll rebuild it. Probably get new sill pads for the transistors, because these things are kind of a one-use item. You don't get as good temperature transmission between the interface once you try to reuse them, so you know, it's a good idea to just get new ones, but you know, they cost next to nothing, so that's fine. And now we magically skip ahead to the point where I have all the new parts lined up and I'm ready to put them in and hopefully get this thing working. Hopefully, anyway. So nothing really tricky about that, it's just a bunch of stuff. We just solder it in and then test it out. The only thing worth paying any note to is probably the fuse. These little end caps on here that solder into the PCB, I pulled those off the old fuse, or at least what was left of it. Just a good idea to hold the caps with a pair of pliers and then pull the metal parts of the old fuse out of them, and then I just pushed these onto the new one. You could buy, you know, a fuse with wires already soldered on it, or you could buy one with caps already attached, but you know, for the purpose of saving as much money as possible, let's just reuse the end caps off this one. It would be nice if they had an actual fuse holder, and I probably could put one on the board if I really wanted to, but yeah, I don't think it's going to matter that much, so I've just reused these. That should be good. There we go. So yeah, just standard glass fuses. I bought a few because I didn't actually have any 8A ones, so yeah. Then we got the rest, got the diodes, got some sill pads for these transistors. I had to buy a whole bunch of those anyway, so that was alright, there's a couple of dollars for that. Some MOVs and a bridge rectifier. I know there's one in there, but that's only for testing, so it's not high enough current to be used continuously. And then we got some transistors. I bought 10 of them. They were really cheap. I figured I'd buy 10 just to have some spare and just for fun. But yeah, I only need 2, so anyway, all up that was only a couple of dollars to get all that stuff. I just added them to some other orders as I ordered stuff from various places that had what I needed, and just, you know, got the cheapest price I could for everything. Alright, there we go. comes out there, so I can just reuse that for something else. So where's the new one? There you go, it's the correct one. It's a GBU606. So it's a 6 amp one, a 600 volt rated, and this one is 405, so I think that's 4 amps, 500 volt rated. The voltage rating is okay that it's only 500, but the 4 amps is, you know, not that great when these are 6 amps, so you know, we don't want to have the current rating like 2/3 of the original. Alright, so let's put this in, make sure I get it run the right way. Alright, excellent. Now, fun part, we're getting all the extra things back in. I'll probably take these capacitors back out again actually, to get access to that. So obviously if you're removing these main filter capacitors, you want to make sure you get the polarity correct when you put them back in, or replace them if you're doing that. And obviously this thing hasn't been plugged in for like 3 weeks, so there's no need to discharge them or even check the voltage. There's not going to be an issue there. So this one's negative here, and that one's negative the other way. There we go, you get those out, and of course it shows on here anyway with a big plus, positive, and this shaded as negative. Again, that can differ between different PCBs. So you should be able to see that, you know, big plus there, that's the positive, that's the negative, but it's not always the same for all of these. Sometimes it's shaded as the positive, sometimes it's not. Most of the time it's negative, but you know, you never know. So let's see, put these actually put the diodes in first. I think will be the easiest way to do this. So these are, I think the original ones were they PF1007 or something. Just a fast recovery rectifier, and these are not the exact same model number of diode, but it doesn't really matter. Sometimes you get the voltage rating and the speed rating the same. It's important with these, you know, if they are doing high speed stuff, that they are in fact fast enough. I mean, that's what a fast diode is. It has a faster turn off and turn on characteristic curve than a regular one. See, a standard 1N404 or something is designed for use on 50 Hz, just rectifying on a standard mains transformer. So it's 50 or 60 Hz. It's very low, very slow. Whereas with switch mode power supply, if it's running like 50 kilohertz or something, if you use a regular diode there, then it's just going to overheat because it turns on and off too slowly, and it's in this like, it's kind of like a MOSFET that's left in the linear region too much, instead of switching on and off quickly. You just end up, it just ends up overheating. There's too much power dissipation. So yeah, so you need to have the fast ones if you're doing something with a high frequency. Oh yeah, that's right. There was a blown diode in the drive circuit. I think it was a 1N4148. I have to get that as well. We've got these MOVs here. You can stick that in. Just want 2 of these. The original ones were completely exploded and I couldn't read the names on them, but these ones I got marked 241. They don't need to be full voltage because we're using the 2 capacitor filtering, so each capacitor only sees like half the mains voltage. In 240 volt mode it sees half, and in 110 volt it's each one sees the whole thing, but it's only, you know, 170 volts when rectified. So yeah, if these were directly across the line in a 240 volt thing across one capacitor or something, then you'd need to have higher voltage rating. But anyway, okay, so those are in there. I can solder that in. Now I don't know, to replace that drive diode
I might need to take the heatsink out. 1N4148. Yep, there we go. That's what we want. Okay. Now, what's the pin spacing on this? About there. Alright, now let's see. Can I sneak this in under the heatsink? Let's see. If I bend the leads just a little bit on the end here, so the diode is like this. Now, if I grab some needle nose pliers, and maybe I can hold it sideways like that, and sort of sneak it in under the thing, and then pull the leads through. Maybe. Sometimes that kind of thing works, but there's not much clearance under this, so there we go. So anyway, that's obviously 5V standby transistor, SVF2N65F. I don't know, I'd expect that to be an integrated IC with MOSFET in it, because there's no like controller for that, unless it's a self-oscillating design with a couple of transistors or something, which it could be. Anyway, that's that there. So now we can stick this new diode in. Now I've already cleaned the heatsink actually previously of any gunk, so it's literally a case of just grabbing a couple of these for the new transistors. 3D209L. Where's the screws? These are the screws. Alright, so now I can just slot these into the holes. Just like this. And then we just got to line these up with the actual screw holes. I'm going to tighten those down so they're holding the transistors in the right way, and now you can solder them in. Obviously trim the leads, and then that's that. Just quickly check that to make sure there's nothing shorted. That looks good. But I did forget to resolder the 5V standby IC. So let's do that, obviously. If that wasn't soldered in, then nothing would happen. Because you need the 5V standby. It doesn't just power your motherboard to be in standby, it also powers all the control circuitry in the PSU, so if it's not running, then all the secondary side ICs and everything don't have any power to do anything with. Anyway, let's put these capacitors back in. So that one goes there, and this one goes here. Just obviously heat these up and then push them down and make sure that they are actually flush against the board. We don't want them half off the board or something. That's all back together. It's got the new transistors, it's got all the new diodes and the new MOVs and everything, new fuse, so that should, a new bridge rectifier, should be all good to go. What I'll do is put this back in here. Make sure we got that insulator there. Okay, so put the screws back in, and then I will attach an external light bulb in line with the power cord, and I'll power it up. What will happen is that it works, hopefully. One moment while I just set that up. Well, that took me a bit longer than I thought to find the appropriate cable to connect up to my dim bulb tester thing, which is just in the old case of an old power supply, scrapped one. So we've got this bulb here, 60 watt, so that's in line with the feed coming into here, and then the other end is this plug here, which goes into the main socket, obviously. So this is in line. If there's a short circuit at all in this, still some issue there, this will just light brightly, obviously, as we saw before, and obviously, as we saw previously, this should just flash briefly once when I plug this in, well, when I switch it on. So let's do that. So plug it in, nothing should happen. If I switch this on, I should get a brief flash, and that's about it. You get nothing. Okay, what's wrong here? Is this bulb still good? Well, that's quite amusing. So it looks like this bulb here was actually blown, and that's why nothing happened. So now I've replaced it with another one. It's actually 100 watt. I don't have another 60 at the moment, but that's okay. It should be alright. Now I'll plug this in and see what happens. Again, we should get a brief flash and nothing else, which we do. No exploding. That's good. So that's a good start. Do we still have a 5 volt standby? Let's use that one because it's got the nice big display on it. For a start, anyway. Alright. So yeah, 5.08 volts, so the 5 volt standby is correct. Now, are we getting PS on? So that should also be 5 volts, or 3.3 maybe. 3.4, 3.5 volts, okay, that makes sense. And if we pull that low, it should activate. Now, I have got a little attachment board thing here. So you should see a pink light on here, that means the 5 volt standby is on. And if I flick the switch, nothing happens. I shall have to investigate that. Okay, so I'm going to try and troubleshoot why it doesn't start up. So I'm just looking at the drive output from the controller IC down here. So got this plugged in to my scope there. It's actually going through the digital one and then output to this analog one. If I plug this in, for example, I mean that's at 0 volts right now, it's just ground. If I plug in the power supply, it goes up to, I don't know, put this on 100 millivolts per division at 10 times probe, so that's about 2 volts, I guess. That's one of the outputs. If I put the switch on, I'll take a couple of, but we do get a drive waveform, pulsing on, coming to the coming out of the controller IC, so it is trying to drive the drive transformer to the sorry, the scope is a bit silly and the digital one is a bit strange, but you can see the waveform there. It is like pulsing, it is pulsing the thing there, so something is happening. If I just go hold that, yeah, hard to see on this, but you know, it is actually doing little bursts of signal there, so it's trying to do something, whether that's the correct thing or not, but it is responding to the power up signals. Could be there's something wrong with the more of the components in the drive circuitry. So as you just saw, I probed the output of one of the outputs from this IC, and I got a 2 volt peak-to-peak signal going into this transistor here, which makes kind of sense. And
and that drives the primary of this drive transformer, which then couples over here and then drives the bases of the main switching transistors. And then the other output I probed, and I got like a 20 millivolt peak-to-peak signal, which didn't seem correct. And if I look at these two transistors here, this one here is the one on the one I was getting 2 volts. It's got a 1.2 volt drop across it, which makes sense. But if I try the other one, look at that, we got a short circuit. So it looks like maybe this transistor here has gone shorted and is causing a problem. So let's replace that transistor. Well, let's remove it and see if the see what it is. Well, that's kind of worrying, because at this point we got possibly damage on the other side of this transformer, which yeah, kind of makes you wonder, is the transformer itself still okay? I wonder if it has a, well, if it has a dead short, that wouldn't measure over here, because this transistor is only connected to the IC and to pull-up resistor and stuff. I mean, it's not even connected, that's the base of that transistor, I guess. So it doesn't really make sense. Of course, transformer could still be bad, I guess, which would be annoying. And I hope not. What is this? It's ST2SC1815G, so 2SC1815. Let's see if we still got a short across these two pads. Nope, now it's 1.5 volt drop, but that's not shorted. The point is, yeah, so it looks like, let's just check that. Yep, that transistor is shorted, so that's probably why we're not getting any drive to the transformer. So this transistor is bad. Okay, so what do we got? 2SC, what is that? What did I say it was? 2SC1815G. Okay, so that's probably just a standard, what is it? Standard BJT. It's probably nothing particularly interesting. It's a like a 1.5 cent transistor. 60 volt, 50 volt rated, 60 volt collector base voltage, collector emitter voltage, 50 is NPN. That's a pretty basic transistor. 80 megahertz. Yeah, that's quite simple, isn't it? That's just a I love this. In the data sheet there's a note that says, on special request these transistors can be manufactured in different pin configurations. Yeah, it's really awesome when they do that. They just make up a completely non-standard pin out, and then you got to troubleshoot something and the thing is completely different. But let's assume that it is in fact normal. Seems to be pretty simple transistor. So if I was to replace this with like a BC327 or something, or 337 or whatever, that would be potentially a suitable replacement, because it should only just be switching on and off. It shouldn't really be doing any anything too complicated, and it's not going to be that high frequency. There's a bunch of diodes there as well. Look like more 1N4148s. Let me check those. See if none of those are shorted as well. 500, 500, 500. Let's check those face. Yeah, okay, those diodes all seem to be alright. There's practically nothing else there. There's just the 4 diodes, these 2 transistors, and then the pull-up resistors for that bases, I think. That looks, I don't know what value those were. 2.2K for that one.
2.2k for that one. They both look alright. Okay, so I think everything there is fine. There's got to be that transistor. So let's replace that. Let's try like a, I don't know. Emitter collector base is the pin out. Okay, I don't have anything with that pin out. That does look like it is correct. Going by the data sheet. I mean, that's got to be the base connection there from this IC, so pin 3 is definitely the base. The other two are probably the same. Hopefully, let's just assume that. Let me grab another transistor. That'll probably work. I mean, it doesn't say anything particularly amazing for this thing. 337 has a lower voltage rating, but it's not by much. Voltage to this should not be anything significant, really. Should only be switching like 5 volts or something. So let's just try that. Should work, I think. So let's just check the pin out. So this is going emitter collector base, but 337 goes collector base emitter. So 3 is emitter. If we face it backwards, so we need to bend the leads like that, and then put this in facing the other way around, which means I need a piece of heat shrink to put over that lead to make sure it doesn't short circuit with the other one. Then put one length on each leg. Shrink that down to make sure it doesn't fall off. That should work though. And then that's just got to face the opposite way to the one that was already in there. That will hopefully work. Now if I'm lucky, this will actually do something and it won't be going up in flames. Now I've put this little coil of wire here through the transformer. If I hook onto that, I should be able to see the drive waveform. Assuming that there is one. Let's plug this in. We get that, makes sense. Haha! Switch it on. No exploderizing. And also, if you notice here on this tester here, we have the lights. Now it's interesting there. Let's see, switch it on. Get 12 volt, 5 volt, negative 12. We don't get a negative 5 obviously because it doesn't have one. It's too new for that. Got a waveform on there now. Haha! It's actually doing something. I'll just record on the other camera. May not be obvious, but you can see a waveform, so that's measured from the around the drive transistor there. So yeah, so that's good. So it looks like the drive transformer is actually okay, which is good. So it's just that shorted transistor. This one here. So it's interesting. Short diode, short transistor on the secondary side. Must have seen a pretty high voltage spike through that transformer. Gone back and blew it up. Okay, so I actually replaced both of those drive transformer and driving transistors with the BC337s, even though only one was shorted. I did that because I didn't want to have two different transistors in a circuit like that, where I think they do need to be matched, so I wanted to have both exactly the same. So yeah, if I switch that on here, I don't know if you can see on the other camera, but there's a drive waveform there. It's about 20 volts peak there. 2 divisions there, we're on 1 volt there and a 1010 probe, so
yeah, it's like about a 20 volt peak signal, and these transistors are around 50 volts or so, so yeah, it should be perfectly fine, even though they are like 10 volts less than the original, which were 60 volts. Should still be alright. So yeah, I can't see any other reason why I should not use them. They just seem to be pretty generic NPN small signal transistors that are just being used to switch the primary of that transformer. But yeah, I mean, that's pretty much it. It looks like it's repaired now, so I can, well, I mean, obviously you want to do a load test on this thing and make sure that it's all functioning fine, make sure the ripple is good. So I would say the primary side got exploded by a power surge or something. One thing definitely worth noting, like I said before, the primary filter capacitors here, because there's two of them and they're in series, and because they either work with half a line voltage on each one, or in the case of 110 volt country, they see each one has the rectified voltage on it, and they put in series to double it up to make it high enough to make the more efficiency for the power supply. If these are like different values, or if the ESR is different or leakage is different or something, you can get an unbalanced problem with the voltage levels on these, and then one of them will eventually see more and more voltage. These are only rated at 200 volts, so they'll have about 170 volts on each one, so there's not much headroom. So if one starts to fail, the other one may end up seeing a higher voltage, and then it may start failing. And then over time things can get so unbalanced that one of them is then overvolted and it blows up, and then that kills the switching transistor because that's got too much voltage. And so if you are repairing something like this and you're doing work on the primary section, or you're replacing these capacitors or something, it's an old one, maybe it's got blown capacitors, and then these are pretty cheap, so who knows what. I did do a test before and they seem to be alright, but you would want to check the voltage across these while it's operating to make sure the voltage is pretty much matched. Make sure there's no sort of weird imbalance going on there. But these ones look alright. The only thing with this, I mean, it is a kind of a budget power supply. For a CoolerMaster one, it's not bad. It is an older design, but it's not bad. You've got the big fan and everything. But these capacitors are still not a great brand or anything at all, and there's probably quite a few years old, so if you do repair something like this, it's still worth to replace the capacitors anyway, at the very least the output ones. They still look okay, they might be fine. I mean, if they're okay, I'd use them until they wore out, but yeah, if you did want to do a proper full refurbishment of something like this, then you do want to replace those as well. Okay, just pop that on for a quick test. Got this back here. Let's see, so let's just stick this on here, show that it is in fact working. So we got that there. So yeah, let's see, negative. So we've got our obviously we've got our 5 volt standby. That's at 5 volts. That's fine. And if I switch it on, fan goes, so that's good. And you can see we got our 3.3 rail. It's 3.3. That's fine. We got 5 volt. It's good. 5 volt there. Got our 12 volt here. It's 12.5. Probably because no load. And there should be a negative 12. Where's that gone? There we go. That's negative 10. Well, yeah. Negative 12 is never usually that well regulated. That's not particularly good, but again, it's got no load, so that's probably why. But yeah, that all seems alright. Do we get power good? Power good is 5 volts, so that's good. So yeah, the thing is, I mean, basically it's fine. We just want to test the ripple and everything, and make sure that's all good, and give it a good load, make sure it can handle a decent load and everything. But that sort of thing would be for another video. I'm not going to do that here. It's already like an hour long, this thing. So yeah, but to just show the basic ideas of repairing a standard sort of power supply like this, just sort of how to go through that if something has blown up pretty catastrophically. The primary side is all a lot of damage there, and even went through to the secondary side. I mean, these transistors, like I said, only rated for like 50, 60 volts. So yeah, I mean, if they're driving a waveform like 20 volt peak in normal operation, I mean that's not going to take much of a voltage spike on the on the hot side to go through back through and create like a 60, 70, 80 volt spike that would actually destroy one of these. So yeah, I mean, and I guess, hey, the transformer seems to have survived. I mean, if you want to be sure about everything like this, if you know the sort of drive waveforms that you're looking for, you can check those and everything like that to make sure it's alright. I mean, obviously for something when you've repaired the high voltage section and you've done some work on that kind of thing, especially if you're changing drive circuits and stuff, you do need to give it a test for a while, make sure nothing funny's going on, make sure it's not overheating, that kind of thing. I mean, if you can hear like funny noises coming out of it, that kind of thing, switch it off straight away. There's something odd going on there if there is, but this thing is practically silent. The fan is actually running so slowly you can't even hear that, so that's pretty nice. If you hear like an audible whine or something, something's unstable or it's not being driven properly, you get that sort of thing. But yeah, I guess that's that. In general, for something like this, it's not really worth fixing. I mean, the cost of the parts that I put in it was definitely lower than buying a brand new one, even for a cheap one like this. But yeah, I mean, if it needs new capacitors, that's going to put the price up a bit more. But hey, I mean, it's always nice to get something going again. And this little tester board thing that I've been mucking around with, you might see these SMA connectors on here. So this is actually going to hopefully be a sort of a breakout board I can use for actually measuring ripple, doing proper load tests on this. These lights are just indicators to show the various voltage rails. There is going to be a dual color LED here that shows the power good signal and the PS on signal, so it'll switch between the two depending on whether the thing's switched on or not. So yeah, that'll come later when I hopefully maybe one day will build a proper load tester that can do all the rails at once and everything. So yeah, I guess that's fixed, I guess that works. Hopefully I'll see you next time.